Hello, everyone. Welcome back. In the last video, we looked at a teaser video of a parking lot or garage door opening system. And we were looking particularly from the perspective of a state model and looking in detail at a specific state and looking at all the different aspects of that state, looking at that model. Today, we're going to go ahead and show you the entire implementation of the system and the entire state model and showing how exactly it functions. So let's get started. Let's take a look at what exactly we are building. We're building something like this, which is like a garage door system. And in this demonstration, I'm using an ultrasonic sensor to detect the vehicle presence. It's a lot easier and a lot better to control an ultrasonic sensor. You can actually dial in how far you want an object to be detected and so forth. So essentially, there are two modes of this system. There's a manual mode where you push the button and the door opens, and you push the button again, the door closes. Of course, the closing is a little slower because it's a safe closing. So let's say when I'm closing, if something were to come in front of the door is going to retract and I'm not going to fall on top of whatever was blocking the sensor. And if nothing were to happen, the door will close and the light will turn off after a little while. So basically, there are two sensors in play. One is this one. This is the one that's detecting an upcoming vehicle. And so that is what is going to help us with the automated part. So when a vehicle is detected, so let's say my hand is the vehicle and the vehicle is coming in. It gets detected, and then when it's trying to come in, then only the door opens. And while the vehicle is at the door is going to stay open. Now, once the vehicle moves off the door and inside the garage, it's going to close the door completely hands-free. And as usual, after a few seconds, the lights are going to turn off. So that is essentially what we're building. Now, remember that the reason why we need that second sensor is two reasons. One is to make sure that while the door is closing, nothing comes in front that could potentially get, crushed by the downwards door. There is also another reason. So let's say a vehicle comes in and just drives off without coming in. We do not want the door to open up. We just want the door to just stay locked, and after a few seconds, the light will turn off as usual. So that's essentially what that second sensor is used for. So what we're going to do today is actually take a look at the object model, the state model, and maybe a little bit of the code as well. So let's share my screen. All right, so first let's take a look at the object model. So here is the object model. And as you have seen, it mostly is very similar to the other object models you have seen in this video series. Of course, this was contributed by someone in the class. So it's looks a little different, colorful, which is something I like. So these two are kind of the controller classes. This one is the primary controller class, and this one is the kind of the model cum controller class for the door. So the door basically takes care of its associations with the motor and the two sensors that it has. The controller has the association with all of the view classes like the buttons, the lights, and the display, and so forth. So that's essentially the class model. Now, there are a couple of ways that this could have been done. I like this way because the door essentially controls all the things that are kind of built into the door. So obviously the motor is built into the door, and the sensors are part of the door itself. All of these other things are likely part of the controller. One would argue that the button could also be part of the door, but as you know, a controller system might be controlling multiple garage doors. So in that case, you could kind of program which button should operate which door. So remember, object diagram or object model is kind of an art. It is basically your design, and it is up to you to create a design that is going to work with your application. As long as you can make this function using your state model and your code, that is all that takes. Of course, this design will allow me to use multiple doors with the same controller. And you can program which button does what and so forth. So that, when you're doing object design, try to think of in that terms that can you make your design more flexible? Can you make it more scalable? And this design is definitely more scalable than having all the sensors also controlled directly by the controller. All right, so let's take a look at the state model then. And we already looked at the first part of the state model, which is this state 0. So this is the one that was part of the last video. So we went into details of this state model, that when you enter the state model, you start a timer that is going to turn off the light after a while. That's how we create the delay. But in order to turn off the light, we do not have to go outside this state. We can actually take care of that right in the state. So that's what those special event handlers were there for. But if the door button got pressed, that's as a system event that is going to take us to this manual open door. So door button gets pressed, we go to this manual open door. Notice that here there is no do. When we enter the state, door is open, and the system is going to stay in the state forever. And the only way for it to exit this state is for somebody to push this door button again, which is when it's going to go to the step 2. Now, this state is important. So let's discuss what happens in this state. So when I push the door button, a couple of things are going to happen. First, the display is going to show closing the door. I guess the light also will turn yellow, which I did not put in the entry. But let's look at what's happening continuously in this state. So when we start pushing, closing the door, we're going to continuously first check before we start closing the door. We want to check if somebody is blocking the sensor. If somebody is blocking the sensor, we detect an object in that sensor, we immediately exit and go back to manual open. Okay, so we do not want to close the door. We do not want to finish closing until we know that there is nobody at that door that could get hurt, or your car could get hurt, right? So basically, like press the door. If I block that sensor, again, it goes right back to state 1. So this needs to happen continuously in that state. Now, the other thing that needs to happen, of course, is the door will be closing, right? So we first check to see nothing is there. If nothing is there, then we start closing the door. Now notice that the safe close method, which is in the object diagram as well. So you see there is a safe close and there's a forced close. Forced close is what happened in state 0. We just close the door shut. We don't care if anything is there, because that's only happening when you're powering on that system. So we don't need to worry about that. But safe close is just closing the door a little bit at a time. And since the state model system is going to do this repeatedly, we can just close a little bit at a time and check and see if the door got closed completely. If it is completely closed, then this event is going to happen. The door is closed, and then we will go back to our idle closed state at that point. So that's essentially how this one works. So if I close the door, when it's completely closed, it decides that the door is safely closed, then it's going to go back to state 0. And as you saw, after a few seconds, the light turned off in that state. Let's take a look at the auto open. So this is where, remember in the last video, we talked about the loop in the idle. Looks like the door is idle, it's not really doing anything, but it is actually continuously checking to see if somebody is coming to the gate. And if somebody comes to the gate, this is where we are going to go into this vehicle approaching state. And this is where it says that it's gonna, say opening, but it's not going to actually open the door right away. We do not want, a car goes by in front of the garage and your door just opens up. We do not want that to happen. So what we're doing is we want to make sure that when we actually see some vehicle, it needs to come to the garage in order for the door to open. Okay, so this is where we start a delay, and if an object is detected, only then we go to the auto open state, which is where we are now. But if nothing is detected, we're never going to go to that state. And after 5 seconds, this delay timer will fire and delay timeout will happen, and it goes right back to our idle closed system. So now we have blocked the sensor, so object got detected. So this event took place, and now we are in the auto open state. In auto open state, when we entered the state, we opened the door. But notice that I still have my hand in front of the door. Door is open, light is green, can't really see it, but here you can kind of see it. And I'm now removing because now you are a car and you are sitting right under the door. You do not want the door to open on top of you and damage your car, right? So you only after the car has moved off. So when the object is no longer detected, that's when we're going to go back to that old safe closed state, the closing state, right? So now the car moves off. Now the door can close and do the same thing like it did last time. So that is exactly what we implemented in this system. So notice that a state model makes designing these kinds of logic so easy because we can do it all in a diagram. I didn't need to show you a lot of code for this. The code is essentially just an exact replica of what you see in the diagram. So let's take a quick look at the code before we stop this video. So let's just go to Thani and take a look at some parts of the code. So as you can imagine, just like before, we created our the instances of all the classes we need. We created our state model. We created the 2 buttons and added them to the model. We created the 2 timers. There is a delay timer and there is a light timer. So we added them to the model. These are the ones that the state model can handle automatically. You do not have to continuously check. But these guys, these custom events, these are the ones that you have to continuously check for. Okay, so that is extremely important to remember that these, just by saying model.add custom event, all you're doing is adding that name to the state model. Now, of course, I probably could have created some Lambda expression, but I think that would have gone more complex than what I want to do in this video series. So I'm not quite going there. So custom event simply adds a name so that you can create the transitions. So you can build the transition table using the names that you have created. And then you have the state entered, just like let's take a look at some of the complex parts. For example, the state event, right? We saw that how that worked. So this is the state event. So in state 0, there are 2 events that we're handling. If light timeout event happens, we're turning off the light. If light press happens, then we flip the light and start the timer. So if you see, if state is 0, if light timer timeout happens, we turn off the light. If the light press event happens, then we flip the light and we start the timer again. And important that when you handle an event, you return true so that the system knows that, yeah, that event has already been taken care of, so we do not need to worry about sending it back up the implementation. let's take a look at some of the state do's. So state 0, what were we doing? We're checking to see if a vehicle is detected. And remember that we're basically doing this as a if. So if a vehicle is detected, then we process this vehicle detected event. So if the door vehicle detected, then we process the event of the model vehicle detected. In state 2, there are more things we are doing, 2 things we are doing. So let's take a look at state 2. When object is detected, we will fire this object detected method transition, and then we start closing the door. And if the door is completely closed, we will fire the door closed transition. So let's see how that works. We'll check and see if object is detected. If object is detected, we process that event. And then otherwise, we close the door a little bit, check if the door got completely closed. If it is completely closed, we process the event door closed. So as you can see that this is how you sort of poll or check for events in a state. You have to kind of do it in the do activity for the state, because that's the one that continues to repeat. If there is something that you have to do like real quickly, you can do that in the state entered. But doing it in the do ensures that as long as you're in that state, the system continues to loop and check for those events to happen. And the same thing for state 3 and state 4. So that's essentially how this beautiful garage door opener was created. And let's quickly take a look at some of the events that take place. So let's take a look at all of the events. So let's clear this out. So now we are in state 0. Of course, you don't see it, but let's go back to state 0 so you can see. Lots of things happened here, but now as you can see, we are now in state 0, and here it's saying welcome, and then it started a timer with 5 seconds. When the timer went off, NeoPixel went off, the light went out. I can manually open the light, turn on the light. Again, NeoPixel flipped, starting timer with 5 seconds. After 5-second timer went out, NeoPixel is off. Notice that all of this has happened in state 0. I never go out of state 0 at this point. So let's go out of state 0. Let's push the door. Now notice that we went from state 0 to state 1. And as I said, we're going to stay in this state forever and ever until I press the door again. So we're going to press the door button. And now it went to state 2. And state 2 was the closing state. And this is where notice that it continuously moves the door until it's closed. And then door closed event happens. Then it goes from state 2 to state 0 on event door closed. And that's where we have seen what happens in state 0 already. So let's go to state 3 by checking that. Now we went to state 3, a vehicle is detected, and notice that after 5 seconds, it goes back to state 0, and in state 0, another 5 seconds, the light turns off. But when the vehicle is detected, we're in state 3. Now, if we go to state 0 now, this is going to continuously, notice this is continuously checking the digital sensor. As long as it stays tripped, it is not going to do anything. But when it comes off, that's when object not detected happens, and it will go back to state 2 and close the door, right? In state 2, let's do how the door gets retracted. So let's say we are in state 2 now. I'm going to start closing the door and so the door was closing, and in between, the sensor got tripped, so the object detected event happened. It went from state 2 to state 1, which is the hold open, the manual open state. So now it's just going to sit in this state until I manually close the door. So that's essentially how this system works, entirely driven by the state model. So as you can see, the state model is super powerful. You can essentially design an entire system completely in a diagram, and how you implement that state model is kind of up to you. But in our PicoLibrary, I have a simple implementation of state model that kind of takes it literally how you define it in the diagram, and you can implement it in the system. So hope that was useful, and I will see you in the next video.